Okay, so now that you've seen how to use a table and a graph to determine if a line is a linear function, why don't you try these two examples? Make a table and then see if it's linear from that. Remember, you're looking for if there is a constant change in x and a constant change in y. Also graph the ordered pairs to see if it's linear, to see if it's a straight line. Okay, so now that you've done the table and the graph, let's go ahead and look at these. So on number 4, notice we've got, here I put everything in the table, 3, 5, 5, 4, 7, 3, 9, 2. The x's are increasing by 2 each time. We know this is a function because I have no, my x values don't double up at all. The y values all go down by 1 each time, so that constant increase of 2 for x is matched by a decrease of 1 for y. So yes, this is a function. Notice when we graph that on the coordinate plane, indeed, we get this straight line with a negative slope. On number 5, if I put these in a table, notice how my x values all increase by 2, but then there's a pattern here for my y values. I go minus 12, minus 4, plus 4, plus 12. So it's like decreasing and then increasing, but that's not a constant change. The change is not the same every time. Minus 12 is not the same as minus 4. Minus 4 is not the same as plus 4. Minus 12 is not the same as plus 12. So that is not the same. So this is not a linear function, even though there is a pattern. You can see the pattern when you graph it, but again, this isn't linear. It's like a cup or something like that. So that's those two examples there. Okay, delete that. Let's talk about another way. So you can tell by, you can tell if it's linear using a table, using a graph. You've got the vertical line test. And you can also tell by just looking at the equation. So on here, let's fill this in. Okay, so a linear equation is an equation that can be written in standard form. Standard form. Okay, well, what is standard form? Well, standard form of a linear function is it's an equation that looks like this. There's two variables, just like in all of these, but it would look like ax plus by equals c, where a, b, and c are constants. And constants just means they are numbers. Okay, so if you can rearrange an equation to get in this form, then you'll know you have a linear function. One thing to point out, notice that, or a couple things to point out here. Notice that first of all, x and y are not attached to one another. They're not multiplied. They're two separate terms. They're separated by a plus sign here. Notice how there are no exponents. So if there's an exponent, notice how x and y, they're not in the denominator. Okay, so if there's an exponent, if x or y are written in the denominator, we don't even have to put it in this form. If we see that exponents or x, y are multiplied together, or we're dividing by x or dividing by y, right away we know it's not linear, it's nonlinear. But if I can rearrange this into this form, well then I'll know it is in fact it is in fact linear. Okay, so let's have. Okay, so that's what I kind of told you was what goes down here. So let's go ahead and fill that in. I kind of jumped the gun a little bit here. So x and y. Let me type, be faster. Okay, so x and y both, maybe it will, have exponents of 1. Next rule. X and y are not multiplied together. All right, autocorrect. And then last of all, x and y do not appear, 3 things, in the denominator as exponents. I'll show you what I mean by that in a second. Or in a radical sign. Now that doesn't just mean really cool. That means in a square root. So you wouldn't have like the square root of x. Square root of x, you can't do that. That means not linear. Or if I had 3 to the y. Notice how that my y appears as an exponent. Again, not linear. And then as a denominator, that would be like 4 over x. Again, not linear. Okay, so those are the things you're looking for. They're not multiply together. It would be like x times y. Okay, and then exponents of 1 means you don't see exponents there, because when there is no exponent written, exponent is 1. Okay, so looking at number 6 then, write it in standard form. Well, if I'm going to write this in standard form, I need to get y over to the other side, okay? So to get y over to the other side, because you want x and y on the same side if it's standard form, we did this back in chapter 2, solving for a variable. So we're going to add 2y to both sides, and I get 3x plus 2y equals 7. You'll notice that's that same form as this up here. ax plus by equals c, where a, b, and c are numbers. So you see a is 3. B is going to be 2. And c is going to be 7. Okay? So this would be a linear function. As far as you'll notice number 7 here is in standard form already, because we got x and y together. Okay, now so the standard form is already there. It's just 1/2 x minus 2y equals 15. Okay, now to identify a, b, and c, a is pretty easy. It's just the coefficient of x. A lot of people think, oh, then the coefficient of y is 2. Well, no, because there's a minus sign up here. That's what this little note up here where it says change the minus sign to adding the opposite. That helps us to identify what that b value is. Because remember, standard form is ax plus by. So in order to make it ax plus by, what we need to do really is we need to change this to adding -2. Remember, subtracting a positive, same thing as adding a negative. So b is not 2, b is -2. Okay, so to make this standard form, I would just change that to plus -2y. And again, that helps us to identify b a little bit easier. So the coefficient of y is -2, and then c is 15. Okay. Oops. Let's just get rid of this. Never mind. I don't want to do that. Okay, here we go. All right, tell whether the following functions are linear. Okay, so refer back to the notes you've written. They kind of ran away on me, but remember, we want to get this into standard form. The other part of the directions here are to, if it is standard or if it is linear, then graph the line. So let's look at this one. You'll notice I don't have x in the denominator. All my exponents are 1. We're not dividing. There's no square roots. We're good to go. I can do this. I can put this into standard form. I just gotta get y on the other side. 2y. And then my equation is x minus 2y equals 4. To graph this, I'm going to make a little t-chart. Okay. So let's say I did, let's just do 0, 1, 2. Okay. I know it's going to be linear. I know it's going to be a straight line, so I'm only going to do 3 values like that. So if I plug in 0 for x, then I'm going to get 0 minus 2y equals 4. So I have -2y. And then divide by -2, y equals -2. So I've got 0, -2. All right, let me erase. erase all that. And let's say I plugged in 0 for x. Then I'm going to get 0 minus 2y equals 4. So I have -2y. And then divide by -2, y equals -2. All right, let me erase all that. And let's say I plugged in 0 for x. Then I'm going to get 0 minus 2y equals 4. 1 for x. Well, then I would need to subtract 1, and I would get negative 2y equals 3, divide by negative 2, and y equals negative 1.5. Okay, next I am going to plug in 2 for x. You know what to do here. I'm just making the video long at this point. I get negative 2y equals 2, divide by negative 2, and y equals negative 1. So now we got 3 points, we're ready to graph it. Okay, so I'm going to use my space over here. For x, I guess got to go 0, 1, 2, and y is going to be in the negative, so I'm looking at a lot of stuff in the fourth quadrant here, so I'm going to go like this for 1, 2, 3, and then my y values go down to negative 2, so I can just go negative 1, negative 2. Let's graph this thing. 0, negative 2, 1, negative 1.5, and 2, negative 1. Well, if I drew better, it'd be a straight line. There you go. Just make my dots bigger. All right, so linear, it's got a straight line when you graph it. It's in standard form where A is, what do we got here? A would be 1, B would be negative 2, and C would be 4. Okay, number 7. Is it linear? No, not linear. And think about why. Not linear because x and y are multiplied. Number 8, right away, should be a red flag. See how x is up here? X is an exponent, not allowed in a linear function. So, not linear because x is an exponent. Okay? Okay, let's take a look at number 9. Okay? All right, number 9, notice there are no exponents. X and y aren't being multiplied together. I could get this in standard form. So to do that, I need x and y on the same side. So I'm going to get rid of 5x from this side. We're just solving to get them together. So putting it in standard form, I'd have negative 5x plus y equals negative 9. So you'll notice this is in standard form. And so yes, it is linear. I'm not going to take the time to graph it. You could do that on your own. Remember, just making an XY table. Since we know it's linear, you can just pick 0, 1, and 2, draw your straight line, call it a day. All right, let's go on to a couple other real life examples. Well, just one. Okay, so on this one here. So at a salon, Sue can rent a station for $10 per day plus $3 per manicure. So the amount each day is given as this function here. F of x equals 3x plus 10. So the function of x is to multiply it by 3 and then add that $10 station fee. All right, so let's talk about domain and range. Remember, domain are those x values. So for our x values, let's change to pencil here. For those x values, it wouldn't be logical to pick negative numbers because you can't have a negative number of days. So here, it would be logical to pick 0. That would be a good one. You could do 0, 1, 2, and 3. Now, think about the days. Could she do a half day? Well, no. They're charging her. If she gets the station for the day, she's charged $10, whether she stays all day or not. And she's making $3 per manicure. You can't do half or quarter or fractional values for x on this one. So this is going to be a discrete graph where we're not going to connect the dots. But we wouldn't stop at 3. You could get this more. She could do more than 3 manicures in a day. So we'll just put ... because we don't know what that upper limit is. So let's talk about the range here, okay? So we're going to make a little, because we want to graph this eventually, let's make a little x and f of x chart, xy chart. So if x is 0, 1, 2, or 3, well, if she does 0 manicures, she still has to pay $10. If she does 1, she has the $10 fee plus 3 times $3 for each manicure. So that's 13. If she does 2 manicures, well, that's $6 she's going to have to pay. So 2 times 3 is 6 and add. So that's add the 10, so that's 16. And then 19 if she does 3 manicures for the same reason. Okay? Notice, x is increasing by 1, plus 1, plus 1, plus 1. And we have a constant change in y. So again, this is a linear function based on the table. We'll also be able to say it's a linear function based on the graph. The range then would be 10, 13, 16, 19, ... Okay, so we got the domain, we got the range. Now let's go ahead and graph this thing. So notice how we have all positive values, and that makes sense because we're talking about days and dollars. So let's just draw a first quadrant graph. Okay. We're going by 3s for the f of x values. So I'm going to put a little break here just so we can start at 10 and number these up real quick. That's good enough. And then I can go just 1, 2, 3, 4, 5, 6, so on and so forth. Just so we get the idea. Label your axes. So this axis down here is the number of manicures. And this axis over here is the amount paid in dollars. Title: amount paid for manicures. Something like that. Okay, now to graph, let me change the colors here. We'll go 0, 10 is our first dot, 1, 13, 2, 16, 3, 19. Again, we're not going to connect the dots because if I connected the dots, I'd be saying she could work like a half a day or 3/4 of a day or 1 1/8 of a day. She can't do that. It's only going to be here, here, and here. Again, it's a discrete graph, not a continuous. Okay. Oh, and everything's getting messed up on this. So hopefully you got all that down. You can use these examples to help you on the homework. And then when you're done with the homework, go ahead and move on to the next lesson.